attack the resin that's around the metal particle, but it can't get to the resin that's behind the metal particle. And so it's a really slow deterioration process with bonded bronze. What ends up happening is the part patinas and dulls naturally outdoors just like a real bronze statue would, and so that actually protects the resin from the UV light. But my recommendation would be either with the epoxy, because we had a customer that did bonded bronze with an epoxy to do medallions for highways in Texas, and they had that combination tested in the lab, and they determined that there was really no deterioration over a 10-year cycle for outdoors, so that's why they went with that material.
Is that bonded bronze that strength to the plastic?
No, anytime you add a filler to these plastics, you actually weaken the material slightly, because it's not all resin, right? You're relying on the resin to bond to that particle, and so you're weakening it slightly. If you want to reinforce the plastic, and we'll talk about how to do the bonded bronze is really just a coating. It's just a coating in the mold, because if you make some of these pieces solid in bronze, it would cost you more than what a real bronze statue would cost, because it's bronze powder, it's expensive. To reinforce these plastics, you want to use a fiber, like chopped strand fiberglass, or fiberglass mat, or fiberglass cloth. That will reinforce and strengthen the casting. Some of these plastics are pretty strong by themselves. I mean, 15, 12, 12X, they're easy flow 120. Like our test with easy flow 120 was to take a hollow part and drop it off our mezzanine 20 feet to the ground. If it didn't crack, we figured that was good plastic. So they're pretty tough on their own, not like a polyester resin. You know, polyester resin that they make boats and car bodies out of, if it's just the resin, you drop it on the floor, it shatters like a lollipop. So it gets all its strength from reinforcement with fiberglass cloth or graphite cloth, or whatever they're using. So resin for resin, polyurethane and epoxy are much, much stronger than polyester. But if you reinforce it with fiberglass, you can make them extremely strong and durable. That's why you can make a boat or a car body out of these plastics. We manufacture some polyurethane foams. We have polyurethane foams, rigid foams. The R2 is a rigid 2-pound density foam. The R8 is a rigid 8-pound density foam. We have a flexible foams. We have the F3, a flexible 3-pound, and the F5, a flexible 5-pound. The density that we specify, for instance, R8, is the free rise density of the foam, which means if we mix up 8 liquid pounds of the R8 pour it into a cubic foot box, it'll rise up and just barely fill that cubic foot. But to get a good part, you have to cast at higher density than the free rise density, so the foam will push itself against that mold wall and get the detail and then form a very thin resin skin. So we might take 12 pounds or 14 pounds of liquid R8 foam, pour it into that same cubic foot box and close the lid. Now there's a lot more foam in there. It wants to get bigger, but the mold holds it in shape, and so we end up with a part that is cast at 12-pound or 14-pound density that has a little bit of a resin skin on it. And that's required to get a good part. These are just free rides. You can see that the surface quality is not great. This one is packed or cast in a closed mold, and the surface is very good. So depending on what you're trying to do, there are different density foam. So if you want to have let's say you want a 8-pound density casting, you don't want to use R8 because that's the free rise density. You might want to use R5 and pack it to 8 pounds to get a good part. And we'll demonstrate a couple of different foams there. The flexible foams are just that. They're foams kind of like a Nerf football or a couch cushion type foam. And again, same thing with a 3-pound and a 5-pound density product. We manufacture a line of epoxy casting resins. We have a clear, unfilled epoxy base called 1010, and we have an aluminum-filled epoxy base called 1030. We have 3 different curatives. We have 1212, 1220, 1230, and different combinations of resin and cure will produce different properties in the plastic, allow you to cast thicker or thinner, give you more or less heat resistance. So the epoxies are the most expensive type of resin that's out there now. Epoxies are harder, right? They get up to a D98 or a D95, so they're very, very hard plastics. But very hard plastics can also be a little brittle. And so you take a plastic like Easy Flow 60, which is a D60, that has some flex to it, some impact strength, so when it hits something, it'll flex a little bit before it breaks. And epoxy, which is very, very hard, doesn't have to bend hardly at all before it snaps. That doesn't mean it's weak, it just means that there's very little flex in it. So it depends on the application which one would be better. These epoxies are also good for doing bonded bronze, but because of the cost, the Easy Flow 60 and Easy Flow Clear have kind of taken over because they're less expensive and really do a similar job. I think Easy Flow Clear, Easy Flow 60 produce a better bonded bronze because they're so low in viscosity that the resin, just the metal powder settles right at the surface and you get a lot of metal, more than you would here. These clear materials are the Polyoptic series, the 14 series. We've got several products in that line, 1410, 1411, 1420, 1412, and so on. These are what they call aliphatic urethanes. These aliphatic urethanes are more UV resistant than the other polyurethanes like the 15 series of Easy Flow. These are what they call the quote-unquote non-yellowing urethane plastics. And I put those in quotes because if you look at these big blocks, they're about 10 years old, and you can see that they're definitely yellow. This is 1420 from 02. Still looks pretty good. So 9 years, almost 9 years old, and still pretty good. So this is what they mean by non-yellowing, right? Yeah, it's non-yellowing, but it will eventually yellow. It just depends on how long and how much UV exposure it gets. These are excellent for prototyping, cast and clear parts. We have companies that manufacture crystal. They make crystal vases and pitchers and chandeliers and things like that. But before they go to the cost of actually casting a crystal piece, they make their parts, their original prototypes, out of polyoptic. Take it to a trade show, and say everybody's like, oh, I love that picture. Then they'll take that and make it out of glass. To get these, you see these, they're all clear and bubble-free because we vacuum or pressure cast the part. If you don't vacuum it or pressure cast it, you're going to get something that looks, even these are vacuum. Well, we're going to do a demo and you'll see you get lots of mixing bubbles. And some rise out, but a lot remains suspended in the plastic. So to get them bubble-free, you really have to cast them under vacuum or pressure.
How can you repair that?
Yep, if you've got a bubble or defect, a bubble is tough because you're going to have to add a little bit of resin in there, and you're going to see it. We had a casting here, yes. It's tough to see this. You hold it in a certain way, you can't see. This is a separate cast piece, and it's a little bit difficult now because it's cut and hazy. Actually, no, this is we made a mold of it. The original one was a clear hand and a clear piece of plastic. Someone made a mold of it and just cast it in one piece. And you used to be able to see the silhouette of the original casting inside. I'm like, wait a second, why isn't this not the same piece? No. So you will see that little bubble. But if you've got a surface like this, you can buff it down with plastic polishes like Novus. Slowly bring it down, like you can start to wet sand it, and you can bring it down. So to get a glossy part, if you want to make this really, really smooth and shiny, you can buff it and get it to be as smooth as you want. But it takes some work to do that. It's not easy to do.
Are you close to clear with the refractive index of that product to match?
Well, the product gets spec'd out with a certain refractive index. I'm not sure, I can't remember, it's like 1.46 or, it depends on the product. 1420 is probably the clearest one that we have. 1411 is probably the next step. So they do have a refractive index, and it's you can only do so much with that. When we make it, that's what it is. You can't make it any better. You can make it worse, obviously, but you can't make it any better. Outdoors, these do pretty well. 4 or 5 years before you start to see yellowing. Like I said, we have that UV additive that you can put in here. The only problem is the UV additive has a slight yellow tint, so you make your part slightly yellow anyway. So it's kind of a waste. But anyway, that's the clear material.